Welcome back to my stomping grounds of Air Turbine, part of what made me the man that I am today with my good friend, Mr. Simon Shane. Simon, it's so good to see you again.
Welcome back, Tony. A great contributor to our company, valued friend for 7 years. I'm delighted to see your success at MTD. I'm very excited to see you on our stand at IMTS today. We have an array of high-speed products to show you that are unique, developed by us, and give you high speed and high power, as you know.
As I know very well, and there is so much technology here. If you like high speed, if you want to reduce your cycle times, you have to watch this live stream on this booth. And with that being said, we're going to send this over to Rowan and Mike, because I know Rowan and Mike have some brand new technology to show you guys from Air Turbine Tools.
Thank you very much, Tony. Now we're going to go on to what I absolutely love. This is an Air Turbine Tool on a torn-off Swiss lathe. Now, these Swiss lathes are absolutely dear to my heart. They're lovely machines, but the driven tooling can't quite get up to super high RPMs. So first of all, could you just show us where the actual Air Turbine Tool is? Because it's absolutely tiny. It fits in with the tiny tools and torn-offs really well.
New 800 series Air Turbine spindle. And as you can see here, it's a 25 millimeter OD, and it will fit into any standard boring holder inside of the tornos.
So it's just it fits in a standard tool pot in a tornos machine, and probably other sliding head leads as well. Yep. But why does it fit so well inside this machine? I mean, if we look at the part over here, why does it make that part so well?
Well, because of the higher speeds, we're able to get better finishes, and we also have 2-micron CIR, which will allow you to get almost no feed lines whatsoever. But also, these machines are designed for small parts and high-speed production with small travel. But the only drawback is the live tooling. So when you're trying to do off-centered cuts, you're limited to 6,000 RPM, whereas this one is 80,000 RPM. So we can exponentially increase your feed rate, which exponentially cuts down your cycle time and increase your profit margin.
And I mean, cycle time is important, but why is it important on specifically a machine like this? I mean, how many parts a month might you look to make on this machine, and what kind of benefits would a small cycle time decrease on a single part give for you?
Well, you could make the difference between 1,000 parts a week to 100,000 parts a week.
Which is huge if you're trying to make orders and stay competitive in what is a difficult world. And investing in just a single air turbine would allow you, I mean, would that allow you to, is it the fact that you can make very different parts of medical that require those surface finishes, otherwise you'd have to take it for a secondary polishing operation. But what are the benefits to what, surely it'd be nice to not have to buy an air turbine tool and polish it otherwise. Why would you want to do that all in one machine?
Well, the problem with polishing is you're relying on somebody's hands, and they can make a mistake. They could drop the part. They can ruin your
form, the dimensional form. On the
right.
part.
Yeah, and then scrap always costs 3 times more than a new part. So if you can do it in here and you cut out all those variables and do it very quickly and make it profitable, then you've made something here.
Absolutely, cutting scrap out, and I guess a person is going to make, you might have, if you've got 100,000 parts, that's a lot of people polishing, and that's a lot of variations in the size in the part, and I guess medical, they want all the parts to be the same every time.
Absolutely, yes.
Brilliant. So medical is absolutely fascinating, and I love these machines, are fantastic. But what about the Air Turbine Tools design? I mean, what RPM can this get to? Surely, at that size, it can't get to much higher RPMs.
Well, actually, these will go 60 to 80,000 RPM.
80,000 RPM?
Absolutely, and it just runs off a clean, dry air.
And what about the heat generated? Surely at 80,000 RPM, they must generate a lot of heat and reduce your thermal expansion, reduce your tolerances. Surely there's a lot of problems with 80,000 RPM.
Well, you would think so, but actually this tool is constantly air-cooled, and there's no brushes, vanes, or gears, so that means there's no thermal growth, and there's no friction. So you can run this 24 hours a day, 7 days a week.
24 hours a day, because normally there's on mostly machine spindles, there's like a duty cycle. They say you can run this RPM for this amount of time, but with these you can run them 24/7.
Yep, no duty cycle, no warm-up, no wires, no extra hoses, just one little air hose, and you're ready to go.
And that's a really simple way of doing things. You don't need any electronics, no controls. You just spin it up, easy as that. Now, that sounds really easy. There must be a reason that people wouldn't want to use, I mean, 80,000 RPM, it's a very high RPM. Surely you want to achieve a certain surface speed with your tool. So, I mean, what kind of tools would you put into the 80,000 turbine tool?
They would be all for micro tooling, which is perfect for the Swiss because it's all about micro tooling. And this allows you to do it much, much faster.
Thank you, Russell. Right, that's enough about the absolutely fascinating mini motor mount. Let's move on to something that I think is really sweet. You guys you're making a chocolate mold here that's making some chocolate now.
Turning metal into chocolate.
Exactly. So you machine chocolate molds here, and these are in brass and in aluminium. And we're doing it on a Haas, it's a VF2. And why would you need an Air Turbine Tool to machine a chocolate mold like this?
Well, molds work always takes a very long time because you have to maintain a very good surface finish. And that means your step overs are going to be very small. And on a slow 10,000 RPM spindle, that's going to take a very long time. So if we can increase the spindle speed, we can increase their feed rate and cut down the cycle time and save them a lot of money.
Absolutely, and normally, I don't know about chocolate molds personally, but injection mold tooling, mold and die, they're very high value, so you want to make sure you can make them as quick as possible.
Absolutely. Automotive industry, there's aerospace, everything. So, yeah, this is a definite game changer for these.
Okay, let's have a quick look at the surface finish on the chocolate. If you hold, let's pick up this as well. So if you compare, you need a good surface finish on the mold to get a good surface finish on the chocolate, and you're showing that really well now here. What RPM did you need for this mold?
This one we were using a couple of different tools. We start out with a 40,000 RPM spindle, and then we finish it with a 50,000 RPM spindle.
Oh my God, and you would never imagine, I mean, you hear 50,000 RPM, you think it's on a really fancy big machine, but you're doing this on a Haas VF2, which is quite affordable for many people. Is this the turbine tool we're putting in the machine today?
This is an example of one of our tools. It's not the exact one that's in here, but it is the 625, which goes 50,000 RPM.
Okay, fantastic. So let's go and can you show us a quick demo? Can we get that running now? Fantastic. So it's really important to reduce your cycle times and maintain a good surface finish, and you can do that on a Haas VF2, which is normally for kind of hogging out big aluminium parts. What are the other advantages to a machine shop that's got a load of Haas machines to just buying one of these Air Turbine tools?
Well, like you mentioned, they have a slow RPM, but they have a very high horsepower, and that's great because you can hog out the material, and then you can put our tool in there and reduce the cycle time for all the finishing, and still utilize their bed, which is still very good. And yeah.
Brilliant. So, and I guess one of the other advantages, because you don't need any electronics, there's no electrical cabling, you can just use a single airline and you can instantly get that 50,000 RPM. Mm-hmm. Now, what about tool changing? Because sometimes you would have to put it in, you set it going, you set the RPM, and then you can press go. And I mean, on a CNC, you want to set it and you want to forget it.
Correct. And if you watch here, I'll show you exactly how easy it is.
Look at this, so we can tool change the Air Turbine Tool, which I personally, I've seen a lot of these situations where you've got to go in, you've got to stick the airline on the rotating tool, and it's all very complicated, but with this, you can actually run this completely unmanned.
Correct, yes. You can run this lights out all night, 24 hours a day, 7 days a week.
But, and also because, I guess, because you can run these 24/7, you don't have to worry about the overheating, about changing with the duty cycles, you don't have to change any tools. And I guess it means that people, do you think that people who've got a set of kind of standard VMCs who have been previously having to refuse this kind of work because they can't make it either competitively or achieve the service finishes, would they be able to achieve, to buy one of these products and then suddenly they've got a whole new roster of work they can take on? Absolutely.
This will turn your older machine into a high-speed machining center.
But how could it do it? I still don't understand how you can achieve 24/7 running. I mean, is there some kind of patented technology? Is there some kind of IP? Surely everyone can use this kind of technology.
Well, the technology is very simple. There's only one moving part, basically, and it's the shaft that floats on two bearings. The turbine is attached to that, so there's no vanes or gears or brushes or anything to cause friction or thermal growth. It's constantly air-cooled, so that makes it so you can run it 24 hours a day, 7 days a week.
That's amazing. 24 hours a day, 7 days a week, air-cooled, doesn't break down. That's absolutely amazing. Now I'm going to throw over to Tony. It's not just 3-axis you can use these amazing Air Turbine Tools on. It's a 5-axis machine as well. Go on, Tony.
Well, now that we've heard from the Tornos area and that beautiful small little tool, then headed over to the 3-axis machine to talk about some delicious chocolate, let's talk about the capability with my buddy Jay Phillips that it's not just for 3-axis, but we now have it on a 5-axis machine as well. So let's talk about the capabilities of the air spindles in general for someone who's interested in upping their RPM on a machine that seems somewhat limited around 10,000 RPM.
Of course, Tony. So our range basically is 25,000 RPM to 90,000 RPM. And this is not a speeder. This is a fully integrated, governed spindle that's air-driven. And we all learned in high school that pneumatic tools bogged down under load, right? So the thing that differentiates us from that is that we have a built-in governor that expands and brings more air to the spindle when it comes under load. Consequently, you can hold 80 to 85% of the RPM that the tool is rated for without losing that. So instead of buying a 100,000 RPM tool to do 50,000 RPM, you're going to get what you pay for.
Well, it's a known fact that small diameters need higher RPM. Otherwise, you're just slowing down the machine and it's going to take forever on the cycle time. But we also know that as you get smaller, precision is key. What type of precision and tolerance do these spindles hold?
2 micron at the collet, which is a very tight tolerance. And I got to tell you, medical, watchmaking, guitar manufacturing, all the way up to aerospace hole drilling and engraving, all these are our wheelhouse. And tolerances are not a problem for us.
Tolerances are not a problem, and you know a lot about the guitars. Now, something else that a lot of people may not realize that we haven't brought up yet, which I think is extremely significant for those people watching out there, is they go, well, what about my main spindle? Because ultimately, the main spindle is locked into place, and it's saving the life of the machine spindle instead of redlining it, because we have to turn it up all the way with a small diameter. We're saving the life of the machine too, aren't we?
We certainly are. But along with that, we have full automatic tool change capability with our spindles, okay? You may not be able to see it from here, but this gives you a good example of how that works. So most machine tools have got a bolt hole pattern on the face of the spindle that we attach a block to where the air comes in. When the tool changes out, fires the air, starts up the spindle. After you're done, it goes back in the carousel, and you can come back and use any other standard tools in that particular run.
And in this world we're talking about right now, the buzzword over and over and over again is flexibility, productivity, automation. Having the ability to rotate this in and out of the tool carousel without any manual loading or unloading. The fact that the main machine spindle locks into place, it can go up to 90,000 RPM without thermal expansion even, running 24/7. This really is the key to those small diameter machining projects that a lot of people have right now, isn't it?
2 moving parts. Basically, you got the turbine, the shaft, and they run on bearings. There's nothing that can hardly go wrong, unless you crash it, of course, or if you operator error comes into play. But, you know, the most exciting thing about this product, I go back to that governor. To be able to run lights out, have no thermal expansion, or minimal thermal expansion, and to be able to run it with the doors closed, I mean, any speeder, most speeders, you have to open the doors, put it in, close the doors, stops production. Somebody's got to be there for that. So we beat that, and we've done it well.
Very well said, my friend. So now we're going to turn this over to Rowan and Gemma to talk a bit more about automation and some of the hand tools. Stay tuned for some sparks, and in the meantime, look at this beautiful piece. Rowan, enjoy the last bit of this show, my friend.
And thank you very much, Tony, again. But we've seen loads of CNC machines today. What we've not seen is them attached in like the wider application space. We've got some hand tools over there, but we've got a big fat robot here. Why would you want to attach an air turbine tool right on the end of a robot, Gemma?
So yeah, absolutely. We have our motors as well, use the same technology, and you can do material removal. You can use it for automation or on a robotic arm for deburring or whatever you're trying to cut. But yeah, would you actually like to try this and see it in person?
I would. Yeah, I do. We've got a dry demo here, so unfortunately the spindles aren't turning. And it does seem like a bit of a shame that you wouldn't, that you got such great technology. You wouldn't just use it in the CNC sector. You could use it for automation, for composite. I guess this is like composite drilling, trimming, everything like that. And I find it fascinating that you can stick 2 on a single robotic arm as well. Why would you need 2 though? Is that for roughing and a finishing operation?
Yeah, absolutely. You could use 2 different tools, and then you can interchange depending on what type of finish you're trying to get or how fast you want to go. Obviously, we're 25 to 90,000 RPM, so you might use different cutting tools at different speeds.
And one of the benefits, I guess, with some spindles, you have to kind of find an electrical feed. You have to do a control feed. You have to set it up. but does the simplicity help an integrator design the end of the robot to make it as easy as possible to get an automated solution?
Yeah, absolutely. We're operated with only 90 psi, 6.2 bar air. So only an airline is used to operate our motors. You don't need a gearbox or a control system. And we have no duty cycle, so you can run 24/7, which is great for automation and robotics.
It's brilliant that you can kind of set and forget these systems, and they're so easy to integrate. And I love, is it a hockey mask we're making here? What are we making today?
Yeah, absolutely. This is a hockey mask that we're simulating the deburring of, and that's an actual application that we have.
So your customers making loads of hockey masks. I mean, how many are they trying to pump out a week, a month? Do you know what kind of volumes they're trying to hit?
Well, with no duty cycle, it's endless.
Yeah, exactly. You could use them for as long as you need to, and there's no downtime. So actually, the bottleneck would not be this cell, whatever kind of process you're using. It would be some other cell, maybe, I don't know, the painting or the polishing or something like that. So, like you said, you did just offer me to go and have a quick go on the hand tools, and I'm so excited to do this. I've been putting it off as long as possible, but I'm going to say I'm a little bit scared. We can go and have a go at the hand tools now, right? My God, because we've got a dry demo here, but let's see what actually happens when we make some sparks, right? That's what Tony likes saying. Okay, so Joe, I'm going to have to give you this mic. Are you sure you can handle it?
I think I can.
She can handle it. Fantastic. Right. So I've got two different kinds here. Can you explain which one? So I've got this one here. What's this?
So this is a pencil grinder. So this would be used for sort of smaller deburring applications. If you want to, we have a slide valve here.
Brilliant.
So you want to slide that on, exactly.
God. And what RPM is this spinning at?
So that's 65,000 RPM.
And I can't feel, normally you can feel like a gyroscopic force, you can feel some vibration on the back end. I can't feel, it's almost like it's not even turning. The only reason I know it's turning is because I can see it and I can hear it. Let's try and make some sparks now. Oh my God. Whoa. And it's amazing how, I've tried to deburr things by hand with a file, and this is a file. This is hardened steel on the surface, and you can see how hardened it is with the sparks I'm making, and I can't even feel that. That is absolutely amazing. And one of the amazing things with these is, even though, it's powered by, I'm going to turn that off now. Beautiful. Even though it's powered by air, it doesn't lose any power. As hard as I press, the governor will open up the O-ring, and it will have more power in the spindle and cut through all that material. Now, shall I go for which one? Is this the Big Daddy?
Yeah, absolutely. So this is our spindle. So yeah, if you want to turn that on and give it a go.
Look at the valve is absolutely huge on this one. I'm going to have to have a go. Oh, hello.
So these are going to be some real sparks.
Oh my God, look at that. I probably need some glasses on or something for this, or some gloves. I mean, look at that. I mean, it's amazing that you'd normally need a CNC to cut this kind of material with an end mill this size, but I'm doing it by hand just because there is so much power in these spindles. And you'd have thought, because I'm making so many sparks, I could feel it on the back end, but this is sweet. I could do this all day. There's absolutely no vibration. I probably wouldn't have to stop and have a break. I could do this 8 hours a day, man. This is easy. Oh my God, that is amazing. And it's amazing to feel. Thank you very much. Well done. Thank you for interviewing me, Jared. Fantastic.
I have a new job.
You definitely have a new job there. But it's amazing to see, because you look in a CNC machine and you imagine, oh, there we go. It's amazing, you imagine there's so much force going through all of those tools in the CNC machine that you need a big, rigid machine to hold it. But with the power in these spindles, you could just do it by just little old me with my little biceps. You don't need much power to hold it. You can really see that low vibration. I mean, operator safety is a big thing nowadays. Do you think that helps with the fact that operators aren't going to have that hand-on vibration syndrome? It helps them, it's better for them and their health and welfare?
Absolutely. At high speed's doing the cutting for you. So yes, you don't have to put a lot of pressure on it. We have no issues with white finger, carpal tunnel. There are no working time limits with our tools. We really pride ourselves on looking out for our operators and our users. So that's a big benefit to them.
And it's great that you guys are thinking about that. I mean, it's completely different. You imagine like a pneumatic drill. If I'd be on that, I could only be on that for 10 minutes. And it's not just the vibrations, but it's the noise as well. I mean, I guess, what about having to wear earbuds, having to wear any kind of ear protection?
Absolutely, no. We're only 67 dBA, so very, very quiet. You don't need to wear earplugs at all. Keeps your operators really safe. There's no heat as well, so people often complain of their pencil grinders or their pneumatic hand tools getting really hot. Not pneumatic, but sorry, electric hand tools getting really hot. We don't have that problem at all.
Yeah, I've done that. I've tried to deburr a bit of like fiberglass with, I don't know if I'm allowed to say it, Dremel. And that's just a bit kind of a cheap deburrer that I bought, and it's not a comfortable experience. Whereas I'm doing it inside a machine tool show, and I don't feel like I've worked hard at all yet. I mean, I don't know. This is a little bit tough, but it's absolutely amazing what these things can do. Shall we move on and then finish with Simon? Simon, do you want to come and have a quick finish? Simon, do you want to finish the stream? So I think Simon's got a few words to speak.
Absolutely.
Thank you very much,
Yeah,
Gemma.
thank you. That was
Brilliant.
great.
So let's get Simon on. I heard you wanted to say something to our viewers. You want to close the
I
stream?
do want to say something to your viewers. If you're ready to step up to 25 to 90,000 RPM with power to 1.4 horsepower that doesn't back off, come visit us at airturbinetools.com or at IMTS or AMB this week. You can try the hand tools yourself. They won't stall, they don't vibrate, they're light and powerful. If you have a CNC machine, 5-axis included, we'll give you far faster cycle times. And there's no heat and no thermal expansion. If you're doing robotics, we mount up in compliance units to do robotic deburring. And now we've added to our program a very exciting development, the 800 series, giving you 80,000 and 60,000 on a Swiss machine. You drop it in, you connect 90 psi, 6.2 bar air. That's all you need to do. So come see us, the destination for high speed, the tools of a new generation. Thank you for your visit.
Brilliant. Thank you very much, Simon. Right, that's it. Simon's a fantastic monologue from Simon. So thank you for watching. Check out Air Turbine Tools. Find them on their website. If you're in Chicago, come to IMTS. Check them out in the booth.